Okay, so you can check. This is after here collision takes place. Okay, here collision. Okay, before collision, you can check its momentum is mass into velocity. Its momentum is 2 into 1, like this. Its momentum is 2 into 1. Here momentum is 1 into 0.5. Its momentum decrease because of collision. Clear? Kinetic energy of this total system is equal to the kinetic energy of this system. System means this two bodies. So initial kinetic energy of system equal final kinetic energy of system. In case of elastic collision, I will explain what is that. Clear? But one thing you must remember, in case of collision, momentum always conserved. Kinetic energy may or may not be conserved, depends on the type of collision. Okay?
Okay, sir.
So accordingly, the collision are classified into two kinds. They are elastic collision, inelastic collision. Okay. Now, what is on the basis of conservation of kinetic energy? Definition of elastic collision: the collision in which both momentum and kinetic energy are conserved. Okay, it's very important. Both momentum and kinetic energy. Clear?
Okay.
Okay.
Yes.
Perfectly elastic collision. If in a collision the kinetic energy after collision is equal to the kinetic energy before collision, that is perfectly like collision between atomic particles. Clear? Bouncing of ball with the same velocity after the collision with Earth. What is the meaning of this? This is our Earth. If you take one ball like this ball is having the mass m. You drop this ball from a height h. After collision with the Earth, it again reaches the same height. It is only possible when kinetic energy initially equal to kinetic energy, or we can say energy initial to energy final. Okay.
Okay, sir. Sir,
Inelastic
one minute, sir.
means
I'm writing the previous slide.
right.
1 minute, sir.
So they can ask what is the example of perfect elastic collision, like collision between atomic particles.
Okay, sir. Okay, sir.
Next is inelastic collision. Inelastic means there is only conservation of momentum. There is no conservation of kinetic energy. Clear? Meaning is what? Inelastic means like this. If you take a ball, it is going after collision, it reaches up to this point. It reaches this height only. Okay.
Okay, sir.
This is inelastic. Okay. Okay. What is the example? Collision between two automobiles on a road. Mostly collision we are seeing in our real life is inelastic. Okay, there is always loss of kinetic energy because of friction. Friction is there. So mostly collision in our real life is inelastic. There is no elastic collision. Perfectly inelastic means meaning is what? This body having mass m is colliding with this mass at 2m after collision. After collision, both the bodies stick like this and moving in a combined velocity v. Okay.
Okay, sir.
We say this is known as perfectly inelastic collision. Okay.
Okay.
So after collision, they stick perfectly inelastic. Maximum loss of energy here. Okay.
Okay.
You know, when like Mason, you know Mason,
Sir?
Mason. This is
No,
the
sir.
ball. You know cement,
Yes, sir.
paste of cement and like bricks. They are forming some mixture, na? They are taking that
Yes,
mixture
sir.
and put on the ball. And after collision, it is stick. Cement is stick, na?
Yes, sir.
It is not coming down, up, right, left. Perfectly inelastic collision. You take cement and put on the ball. Wet cement, okay?
Okay, sir.
That is perfect example of perfectly elastic collision. Here, two bodies stick together or moving with the same velocity after collision. Collision between a bullet and a block of wood into which it is fired when the blood remain embedded. Okay, is it clear?
Yes, sir.
Easy only. Okay. So elastic collision
Okay.
means momentum and perfectly elastic means momentum and kinetic energy both conserved. Perfectly in a but not inelastic means inelastic. I'm saying inelastic. Inelastic means momentum conserved, kinetic energy not conserved. Perfectly
Okay.
inelastic. Here also same thing. Clear? Is it
Yes.
clear?
Yes, sir.
On the base first is on the basis of kinetic energy. Now it is on the basis of the direction of colliding body, like head-on collision. That is one-dimensional collision. What is this? In a collision, if the motion of colliding particle before and after the collision is along the same line, the collision is said to head-on. Means is what? Like these two balls. Clear? This ball, this ball. They are moving like this. This is you can say 1 meter per second. This is 4 meter per second. Okay.
Okay,
You
sir.
can take this is 2m. Once they collide, they are collided. After collision, they are moving along the same line of motion. Same line, okay. This is also
Okay.
like decrease like 2 meter, decrease to 3 meter. If you check the line of action, you can say what is the head-on means. The motion of colliding particle before and after is along the same line. There, motion is along the same line. Motion is along the same line.
Okay.
Same line. In this same line, it is motion, na? Same line. Motion is along the same line. Before collision, see, it is moving along the same line. After collision, it is moving along the same line. Clear? It is known as
Okay.
head-on collision. Okay? This is known as
Okay.
head-on collision. Now, one is oblique collision. What is oblique? So, oblique means if two particles collide, if the two particle collision is glancing, that is such that their direction of motion after collision are not along the line of initial line of motion. They are colliding in such a way that their direction of motion after the collision are not along the initial line of motion. The collision is oblique. In an oblique collision,
Okay.
particles before and after are in the same plane. They are in the same plane. This is very, very important. After and before, they are in the same plane. Very important. The collision is called 2D, otherwise 3D. Collision of blade balls. You know blade balls?
Yes, sir.
Many balls are there. You take one ball, take one stick. When you strike,
Yes, sir. I have seen,
ball
sir.
strike this, strike here.
Did you go to the table end?
Sometime what happen? This is rest. You are throwing a ball. This ball is going to touch like this, moving like this. After this, it is going like this. Okay, blade ball.
Okay, sir.
So there, initial line of motion, whatever it is, clear, such that their direction of motion after a collision are not along the initial direction of motion. Oblique. Oblique means certain angle. But
Okay, sir.
it should be in the same plane. That is very. When billiard balls you are playing like this, billiard balls, then all the balls are in the same plane. So this that is oblique collision. Okay.
Okay, sir.
Tell me.
Sir, momentum, but neither kinetic energy nor temperature. Sir, always less than the before collision. B, option B.
Clear? Maybe less or greater than now.
How, sir, it can be greater?
A or it may. You please tell me. In an inelastic collision, the kinetic energy
Okay,
after
sir.
collision, it may be less or it may be greater. For example, this is 2 kg mass. This is 1 kg mass, and there is a inelastic collision. This is at rest. Okay,
Okay, sir.
it is 4 meter per second. Once it is collide, after collision there is stick. Inelastic na. Let us suppose it is moving with
Yes,
the 4 meter per second. Let us suppose.
sir, then perfectly inelastic only, no, sir.
Inelastic.
Okay, sir.
Inelastic na. Inelastic two types. It may be perfectly, it may be without perfect.
Okay, sir.
Perfectly inelastic, it will stick. That is inelastic, na? Actually.
Okay, sir.
Maybe less or greater than the collision. Now, one dimensional elastic collision and a special case. Let us consider two spheres having mass m1, m2. They are moving with initial velocity u1 and u2 in the same direction, and they collide such that after collision their final velocity are even. You know what is this before collision? During collision, what is happening? F1, F2, these are
Yes.
normal. No, once they collide, na, shape deform like this. They are normal. This is F1, F2 is actually normal. Okay, normal of this will be like this. Normal. Clear? It is
Okay.
perfectly elastic collision means after collision, it will gain its shape. Exact shape it will gain. There is no deformation left. Otherwise, some energy is going to lost in deformation. Deformation.
Okay.
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 We can check this diagram. See, motion is along the one line. Motion before along this line, and after also along this line, same line. That is why it is known as one dimensional elastic collision. Head-on collision. It's known as, its name is head-on collision.
Okay, sir.
So if you apply the conservation of momentum, initial momentum, this is our system. Okay, this is
Okay, sir.
our system. Is there any external force?
No, sir.
Zero. So we can conserve the initial. This is final. The initial momentum of system equal final momentum of system. Initial is m1, 1, m2 equal m1 d1 2. Okay.
Okay, sir.
See this collision, the impact na here impact. This impact na, this impact is acting for a short time. This is impact.
Okay, sir.
For sure. Clear?
Yes, sir.
You can check. Okay. M1,
Okay.
U1 plus M2. You can take M1 common. U1 minus V1. M2. V2 minus U. Okay.
Okay, sir.
What is this? You want to write, you can write like this. V1 minus U1. Okay. Equal V2 minus this U1 now. V2
Yes.
minus this equation you will
V2.
get. Okay. Okay.
Okay, sir.
So kinetic energy before collision, half m1 u1 square, half m2 u2 square, half m1 v1 square plus half m2 u square.
V2.
Okay.
Okay.
This is the derivation. It will come in your exam. So basic, easy only. But did you
Okay.
notice one thing here? One important thing you got. Initially, see this ball initial m1 1 initial velocity power. Oh my god, power. First time it happened actually. Hmm. So it is moving with the u1. I think internet is working. Oh my god, stop. I think maybe my net will disturb. Okay.
Okay, sir.
So what I am saying, see, current slide. We get one. Oblique collision we have finished. This we have discussed.
Yes, sir.
What we get finally up to this. Okay. So it
Okay.
is moving with u1 initial condition. Okay. u2 after collision v1 it is v2. Okay. Before collision, after collision.
Okay, sir.
So what you are getting like u1 minus u2 equal v2 minus v1. You just imagine in your mind u1 minus v2 means u1 is more than u1. u1 is more than u2. Here v2 will be more than v1. Why? It is collision will happen only when u1 is more than u2. They are moving in this direction. Okay.
Okay, sir.
And after collision, its velocity will m2 velocity will increase and m1 velocity will decrease. Okay. So actually, what is this
Okay.
u12? It is velocity of approach. You can write this is velocity of approach. And what is this? Velocity of separation. They are going to approach now at this velocity u1 minus u2. Name. and this is velocity of separation. Actually, it is a relative
Okay.
velocity. If you want to write, you can write u12. It is v21. 2 is going to separate from 1. But its velocity is more after that. This is very important. Okay. In first case, this is m2,
Okay.
this is m1. M1 is coming, approaching. That's why velocity of approach. After collision, it gets slow down. It is moving like this. Separation increase. That is why velocity of separation.
Okay, sir.
Okay. So you
Okay, sir.
can, in case of elastic collision, velocity of approach equal velocity of separation. Okay. U1 minus U2,
Okay.
V2 minus V1. That is very important. Relative velocity, what I am saying, relative velocity of approach before collision is equal to the relative velocity after separation. This is simple derivation, okay? This thing you should
Okay, sir.
remember, okay? This what is V1, what is V2? Either if you remember, okay, otherwise no need to worry. Just apply conservation of momentum, you will get. Okay.
Okay.
If you want to learn, you can learn like this. What is V2? I will write here. V2, remember, okay? V2 is what? 2m1 by m1 plus m2. Okay. Plus upside m2 minus m1 by m1 plus m2. Here u1, I think u2. Okay. V1
Okay, sir.
just change. In place of m1 put m2. In place of u1 put u2 like this. You can check also previous case. Next slide. V1 2m2 u2. Okay. Same thing.
Okay.
Just a change. Okay. V2 is 2m1 by m1 plus m2 u1. But remember this. Okay. V1 is very easy. Replace m1 m2. In place of u1
Sir,
u2.
will we use this to answer the questions numerical?
But I think I will say to you, better no need to remember this. Okay. Just you
Okay.
can apply conservation momentum, you will get. Okay. This is just
Okay.
special case. Special case I'm telling, if two bodies having equal mass, then their velocity exchange. Meaning is that if this object is having the mass m, this object is having the mass m, clear? If it is moving with 4 meter per second, it is moving with 2 meter per second, clear? After elastic collision,
Okay.
previous body velocity exchange, it is going away.
2 meter per second.
I don't know, it is velocity, it is 4, it is 2. Okay,
Okay.
like this, v1 equal to v2. v1 is equal to u2. u2 means this, like this. And v2 will be u1. u1, okay? Same nature,
Okay.
like this. Both exchange. But if mass is same, elastic collision, okay? Condition is that. Okay?
Okay. Okay.
You can write also, it is written there. In case of head-on collision, if two bodies have equal mass, the bodies simply exchange their velocity after collision. Case second.
Oh. Sir, can you show the previous slide writing?
Uh,
Okay, sir.
Clear? V2 is equal to U1, you can check.
Yes, sir.
Second, after collision, V2 is moving with U1, okay?
Okay, sir.
Before collision, first body is moving with U1, second body is at rest. Clear? After collision check, is G check, it is U1, its velocity is 0. After collision, it become 0, it become U1. They are having same mass. It is possible when I have same mass. Velocity exchange. Clear?
Okay, sir.
Okay. Now this.
Okay.
This is smaller body, very, very light body, car. And this is truck, heavy body. M2 mass, M1 mass. It is moving with 1 meter per second, okay? And it is at rest.
Okay, sir.
So after collision, it bounces back. Heavier object will not move, okay? It is very heavy. But lighter object,
Okay.
after collision, it bounces back with the same velocity. That is a concept. It will remain rest. Here, when a smaller body collides with a heavier body, then the lighter body after collision move with the same velocity. It bounces back with the same velocity. Okay,
Okay. Okay.
that's all. That's they have written. And when a heavier body, when a truck having mass m1, it is moving with, for example, 4 meter per second. It is colliding with a lighter body, which is at rest. After collision, there is no change in the velocity of truck. Okay, it's still moving with 4 meter
Okay,
per
sir.
second, but the lighter object move with twice the velocity. Twice. Like how much? 8. So it is very light. Like a bullet, it will fire. There after collision. Clear?
Okay, sir.
Same thing they have written. You can check. V1, V2 is twice of U1. So what is this? A body of mass M1 collides head-on with another body of mass M2 at rest. The collision is perfectly elastic. Okay.
Okay, sir.
Then fraction of kinetic energy transferred by the first body to the second body. Fraction means, you understand?
Yes, sir.
How much kinetic energy transferred by the first body to the second body divided by total. These questions, many questions are coming like this. You don't no need to remember, okay? Later you understand.
Okay, sir.
Tell me the answer.
Sir, 1 minute, sir. Sir, when the mass is equal to the mass of the stationary particle, A.
Yes. Thank you.
Sir, option D.
Heavier particle, na?
Oh, okay, sir.
It will move twice, na?
Yes, sir. Yes.
Hmm.
Sir, 1 minute, sir.
Hmm?
Sir, M2 greater than M1. Option B.
Yeah. Now perfectly inelastic collision in 2 dimension.
Okay.
Consider two bodies of mass m1, m2 moving velocity u1, u2 along a straight line. U1 is more than u2. Okay. Perfectly inelastic. Let them move with common velocity means stick. Here these two bodies stick. This is stick. And it is moving with a common velocity. This is common velocity.
Okay, sir.
Okay.
Okay, sir.
Any doubt?
No, sir.
I think it is easy for you.
Easy, sir.
Easy?
Yes, sir. Easy, sir.
No explanation required, I think.
Sir, I can understand it, sir.
Yeah.
By reading.
Total loss, how much? Final minus initial. How much loss? Kinetic energy final of system minus kinetic energy of initial of system. This is the loss of kinetic energy. Okay? Loss.
Okay, sir.
How much loss? There, confirm there is a loss. Okay? No need to remember this formula. Concept is very important.
Okay, sir.
Now collision in 2 dimension. Consider two bodies, each of mass m. Before collision, after collision. Can you check? This body
Yes, sir.
is colliding with this particle. It is going in this direction. Okay? It is moving in this
Okay,
direction.
sir.
It is oblique. Okay? Line of action of different. Okay?
Okay, sir.
Like this. Okay? V1, V2 with the final
Okay, sir.
velocity after collision. Momentum conserve. You conserve the momentum in x and y. See, its velocity component. One is V1 cos theta. One. Okay? Here V1
Okay, sir.
sin theta 1. Here V2 cos theta 2 down. V2 sin theta 2. This is y-axis. This is x. So momentum along x-axis conserved. Initial momentum along x-axis equals final momentum along x-axis. Initial momentum along x-axis, check. I'm into u.
Yes,
X
sir.
direction. It is having 0. After this x direction, both are clear. M V1 cos theta 1 plus M V2 previous topic clear to you now?
Yes, sir.
Okay. So I think we have discussed this. So also we have discussed. Now perfectly inelastic collision and 2 dimension. Okay. 2 dimension means
Okay.
x and y. Clear?
Yes, sir.
So consider two bodies of mass m1 and m2 moving with a velocity u1 and u2 along a straight line and undergo a perfectly inelastic collision. Yeah. Did I discuss this?
Okay.
Let me check. I think I have discussed this also. Yes, we have discussed.
Yes, sir.
Oblique collision we are discussing. Now this collision in two dimensions. For example, consider two bodies, each of mass m. Clear? Before collision, this is at rest. Red one is at rest. Okay. It
Okay,
is
sir.
not moving. Previous one is moving. It is at rest. Okay. It is moving. See, the line of action of motion is line of impact, and line of action of motion is before collision is this. Okay. After collision, it is moving in this direction. It is moving in this direction. Okay. Then
Okay, sir.
if v1 is this component will be v1 cos theta 1. One component will be v1 sin theta 1. Clear? This ball has velocity here v2 cos theta 2. One velocity will be v2 sin theta 2.
Sir, what
Clear?
is, sir? How can, sir, can't understand, sir, that V1 and V2.
See, after collision, this ball is going with a velocity v1. Okay.
How can it move in two directions, sir?
Just we have considered now like this. It collide after collision. After collision, this ball. After collision, this. One ball is going in this direction. One ball is going in this direction. It has velocity v1.
Oh,
It has velocity v. From the line of action
okay.
of motion, it is making an angle theta 1. It is theta. This is before collision, after collision. Okay.
Okay, sir.
So that's why I have taken a component of velocity. So here particle motion in 2D. 2D means two dimension. So conservation of momentum we will apply in x and y both. Okay.
Okay, sir.
X or y, you can see the x axis. This is x and this is y. Clear?
Yes, sir.
Along x axis, if you look at what is the momentum, initial momentum along x axis equal initial moment, final momentum along x axis. So initial momentum along x axis will be initially. Is now
Yes, sir.
check x. Okay. Second ball is at rest as 0. Finally, x. See the x. This ball has component in x direction. v1 cos theta 1. Okay. So m
Okay.
v1 cos theta 1 plus the second ball m v2 cos theta 2 along x axis. Equation. Okay.
Okay, sir.
Similarly, in y direction, we will do the conservation of momentum in y direction. Why we are doing this? Because body is moving in two dimension. Otherwise, directly I can apply pi is equal to pf. Net momentum change will be 0. There is no change in momentum means there is no change in momentum in x. There is no change in momentum in y. Clear?
Okay,
In
sir.
y direction, if you look at carefully, it is not moving in y direction. So it has 0. Both are having 0 momentum in y direction. But this ball has momentum in y direction after collision. M v1 sin theta 1 and it is going down. This v2 sin theta 2 will be like this. Down. Down means negative.
Okay, sir.
Like this. So from here you got v1 sin theta 1 equal v2 sin theta 2. Equation 2.
Sir, Sir, can you please repeat how pi y is 0?
See, this is initially before collision, it is moving in x direction only. I think it is not moving in y direction. Nah? In y direction, if you
Okay, sir.
check, it is making 90 angle. With y, it is making 90 mean u cos 90. It has no component in y direction. That is why there is no momentum in
Okay.
y now, initially.
Okay.
This is before collision, is after collision. After collision, it is moving in x and y both. But before collision, impact is like it is at rest, it is striking like this. This is after collision, like this.
Okay, sir.
After collision, like this. Before collision, only x direction. Clear?
Okay, sir.
Same thing has been written. Elastic collision, momentum will conserve along x-axis. Okay. Same thing they have written. Mass common. Okay.
Okay, sir.
This is basic calculation. Okay. Everyone can do it. You are not supposed to read line by line. You should understand the concept. In every collision chapter, if you take system of two particles or whatever else, there is no change in momentum. Momentum remain conserved. Initial momentum is equal to final momentum. But we can't say energy will remain conserved. Okay.
Okay, sir.
Momentum always conserved, whether it is elastic collision, inelastic collision, any type of collision, momentum remain conserved. But kinetic energy, it may not. In case of perfectly elastic collision, initial kinetic energy of system is equal to the final kinetic energy of the system. I'm not saying individual, okay? I'm saying initial
Okay, sir.
kinetic energy of the system is equal to the final kinetic energy of the system. But in case of perfectly inelastic, it is not so. Some loss of energy is taking place. Okay, inelastic. Okay,
Okay, sir. Okay, sir.
conservation also we have applied directly. And now you don't say, sir, why are you not applying conservation in x and y direction? What is the use? Conservation of energy. Initial energy is equal to final energy. Clear? Directly we can apply.
Okay.
So theta 1 plus theta 2, hence two equal mass undergo oblique collision. Will move at right angle after collision. Very, very important. See, this body is having the mass m. This body also having the mass m. After collision, one ball is going like this. Okay, one ball is
Okay,
going
sir.
like this. It is making theta 1. It is making theta 2. Clear?
Yes, sir.
So according what we get, what is the outcome? Theta 1 plus theta 2 is 90 degree. This theta 1 na, plus
Yes, sir.
theta 2 equal what? 90 degree when same mass. Object which is colliding, same mass obliquely. And collision type is elastic. Direct question they can ask in J. And condition is second body is at rest. Clear?
Okay, sir.
Is it clear? But elastic
Yes, sir.
collision must be. Okay?
Sir, can you please repeat it?
I'm saying if two objects collide obliquely
Okay, sir.
and one object is at rest, both objects is having the same mass. After collision, the angle between them will be 90 degree. Theta 1 plus theta 2 will be 90 degree.
Okay, sir.
Clear? For example, it is colliding with this is colliding with this like this. After collision, they will move like this 90 degree. Clear?
Okay, sir.
Meaning is that
Yes, sir.
I'm saying
Sir, only sir, I'm writing the previous slide, sir.
please
1 minute.
right.
1 minute, sir. Yes, sir. Completely. So perfectly inelastic. So 1 minute, sir. Body. Sir, V/2. Sir, your mic is off, sir. Sir, your mic is off, sir.
Have you written this? Actually,
Sir, no, sir.
one
When you're
is moving
explaining,
like
you
this.
turn off
Okay,
your
one
mic,
is
sir.
moving like this, but direction of velocity is opposite. So mv minus mb. Okay,
Oh, okay.
after collision they stick like this. It is moving with 1 meter per second. It is moving with 1 meter per second. 1 kg mass. 1 kg mass. After collision they stick. Once they collide they stick, and velocity becomes this combined velocity. Clear?
Okay, sir. Yes, sir.
Which of the following is not a perfectly inelastic collision?
Hmm.
Perfectly inelastic collision means one body will stick with the other body. That is the meaning of
Sir,
perfectly.
sir, striking of two glass balls.
Yeah, correct. Now head on inelastic collision. Okay.
Okay, sir.
What is this? E. Let two bodies A and B collide inelastic. Then coefficient of restitution. See, I told now one thing. This is the M1 mass, M2 mass. It is moving with U2, U1 initial velocity. After collision, M1 is moving with V1, M2 has velocity V2. Clear? U1 is more than
Okay.
U2, then only collision will happen. But after collision, V1 becomes less than V2. Okay.
Okay,
Now,
sir.
I told like velocity of approach, relative velocity of approach will be relative velocity of separation in case of elastic collision. So velocity of approach, you just tell me, it will be D. This is going to approach this because U1 is more than U2. So it is going to approach. So U1 minus U2. Because of this, V2 is more than V1. That is why separation will increase. So V2 minus V1, higher minus lower. Clear? Is it clear to you?
Sir, what is that? Sir, what is that E, sir?
this V2 final velocity, V1 final velocity.
Okay, sir.
It's the relative velocity of approach of first body with respect to second body. So relative velocity of second body with respect to first body. Clear?
Okay, sir.
This is concept because we derive this formula. U1 minus U2 equal V2 minus U1 in elastic collision. Okay, elastic collision we have derived this. Velocity of approach. This is velocity of approach. Relative velocity of approach. And what is this? Relative velocity of separation.
Separation.
This is what we have derived. Clear? But
Yes, sir.
in many cases, like in elastic collision, we can say velocity of approach is equal to the velocity of separation. We can say velocity of approach is equal to the velocity of separation in case of elastic collision. Elastic collision. But what about the other collision? What about the other collision like perfectly inelastic collision? Clear? What about these collision? So in that case, we are using a term coefficient of restitution. It is just a ratio of, what is this? It is a ratio of velocity of separation divided by velocity of approach. Okay.
Okay, sir.
Why we are using? Because in case of inelastic collision, both are not equal. Where perfectly inelastic collisions, relative velocity of separation is, you just tell me, perfectly inelastic collision. After collision, body is stick. Then velocity of separation, 0. Then E will
Okay,
be 0. Clear? E will be 0 for
yes,
what?
sir.
Perfectly inelastic collision. And
Okay,
E
sir.
will be 1 for what? Perfectly elastic collision. Velocity of separation is equal to the velocity of approach. So it is a ratio of separation, velocity of separation to the velocity of approach. Okay?
Okay, sir.
Is it clear to you?
Yes, sir.
This is very, very important. But you just tell me a collision which is neither elastic nor inelastic. Then for that, its E value will lie between 0 and 1. Clear? Which is neither
Okay.
partially elastic, partially inelastic. Their E value will lie between 1 and 0. 0 means perfectly inelastic. E is equal to 1 means perfectly elastic. Okay?
Okay, sir.
Any doubt?
No, sir.
Head-on collision, okay? Head-on. This is no need to learn this, like what they are doing. You just understand the meaning of E. E will be separation, velocity of separation by velocity of approach. You just tell me, if I ask, it is moving with 10 meter per second and 2 kg, and it is moving with 2 meter per second. Mass is 3 kg. After collision,
Hello. Okay, sir.
2 kg is moving with 5 meter per second, and 3 kg is moving with 12 meter per second. Now you please tell me here. You please tell me 2 kg. The 10 is more than 2. Then separation will decrease or increase. If you,
Sir?
my question, listen my question. 3 kg is moving with 2 meter per second. Okay, just imagine like this. This is 3 kg, this is 2 kg. Okay, 3 kg is
Okay.
moving with 2 meter per second, and 2 kg is moving
Okay.
with 10 meter per second. Then approaching. Okay, it is going to
Okay,
approach.
sir.
At what velocity it is going to approach? Relative velocity of
At
approach will be 10 minus V1 minus V2 na? V1 minus V2.
yes, sir.
This is the approaching velocity. At this velocity, it is going to approach. Relative velocity. What is this? U12. U1 minus U2. This is what we have learned now. This
Okay.
is U1 means velocity of 1 with respect to 2. Observer is here. Feeling is there.
Okay,
Okay.
sir. Okay, sir.
Here similarly, velocity of, you just imagine, after collision it is going with 5 meter per second. It is going with 12 meter per second. Then separation will increase.
Separation.
That is why it is known as separation velocity. Velocity of separation. And it will be higher minus lower. 12 minus 5. This is the velocity of 2 with respect to 1. Means observer is here. Okay.
Okay, sir.
Now you can check. Approaching velocity is 8. Separation is 7. Then what is the E? 7 by 8. It is less than 1. So which collision? Neither elastic nor perfect inelastic. It is partial. Okay. Partial elastic. You can say.
Okay, sir.
Okay. No need to learn this. Okay. This is all.
Okay.
I always recommend my students. No need to learn any formula. Learn the concept. Then apply. Then only you will have good grasp on physics. If you really want to excel in physics, always learn concept. Okay, don't muck up the formula.
Okay.
What is the answer?
1 minute, sir.
Inelastic, na? Yesterday, I think you have
Yes, sir.
solved this question. Yeah, we discussed
Yes,
this.
sir.
Tell me the answer.
Okay.
What is the answer? Solve this. Now apply conservation of momentum. Give me the answer. Can you solve?
Sir, I'm trying, sir. 1 minute, sir.
You try. I will also try.
Okay.
Very easy. One sphere, same mass. Okay, this same mass, same mass. It is at rest. Inelastically, okay.
Okay, sir.
If the value of coefficient of restitution means E will be half. The ratio of their speed after collision. Okay. But I think they didn't
Okay, sir.
mention like, okay, we try this. Is it doing with U velocity? Initial momentum as 0. After collision, it is having V1 velocity is V2. Okay. But I think they are asking E is given half. So E will be V2 minus V1 by U will be 2V2 minus 2V1. Mass cancel. Okay. From here U will be what? V1 plus V2. 2V2
Oh,
2V1. Minus V2 plus so V2 will be ratio of their speed after collision. Okay.
okay, sir.
1:3. Okay. Is it okay?
Okay, sir.
Is it clear? Any doubt?
Sir, yes, sir. No, sir.
Say, did I learn any formula? Tell me. Did I learn any formula?
Sir,
We
no,
apply
sir.
concept.
Coefficient.
And what they are writing V1 by V2 is equal to 1 minus C. what nonsense they are doing, like v1 by v2 1 minus c by 1 plus c. This is what you will find in NCERT, these things. But if you learn concept, there's nothing to worry, no need to worry. Okay.
Okay.
Coefficient of restitution, like the coefficient of restitution between two bodies in a collision is defined as the ratio of relative velocity of separation. That's what we have learned. Here v separation by v approach. Separation velocity,
Okay.
approaching. Okay.
Okay, sir.
The value of coefficient of restitution is independent of the masses and the velocity of colliding bodies. Depends on the nature of colliding body. Okay. E, value of E. The value of E, this is very, very important. It is independent of the masses. Clear? And it is independent of the velocity of colliding body. It does not depend on the velocity of colliding body. Depends on the nature. If the nature of collision is elastic, E will be 1. If the nature of collision is perfectly inelastic, E will be 0. Clear?
Okay, sir.
Like this. For inelastic collision, the value of E lies between 0 and 1. This is what I have already explained. Okay. Is it okay?
Yes, sir.
Any doubt?
No, sir.
Now, determination of coefficient of restitution. For example, there are two materials. One is ball, one is the surface on which this ball is going to hit. Okay. One of them is taken in the form of very heavy plate and other in the form of small sphere. Two bodies. Clear? How many bodies are here? One is this heavy plate. Okay.
Okay, sir.
Like this. From h height, you are dropping this, and u1 is the velocity just before hitting the plate. Okay. Is it okay?
Okay, sir.
Now let the sphere
Okay,
rebound to a
sir.
height h1 after collision with the plate. After collision, see, once it is colliding like this, this is a plate. Here it is coming, colliding. At what velocity? u1. Clear? u1.
Okay, sir.
After collision, it is going with v1. It reaches up to this point. This height is h. This height is h. Okay.
Okay, sir.
Now, did you see one thing like here? What is the, if I ask, E will be v2 minus v1, u2, u1 minus u2. This is first body, second body. Okay. Here,
Okay.
second body is at rest. Okay.
Okay, sir.
So, what is the velocity of second body? That will be u1, 0. Even after collision, v1 of what? First body, v2 of second body, it is 0. Minus v1. So, E will be minus v1 by u1. You please tell me, what is u1? It is free fall, okay? Free fall. Did you give
Okay.
any initial velocity? Can you please find the u1? Under root?
Sir, minus
Initial-
V1 by E.
u1 will be u1 square, initial square, free fall. 2 acceleration is how much? Minus g. It is going down. Down means minus. So u1 will be under root 2gh. Okay.
Okay, sir.
Similarly, can you please find what is v1? v1 initial velocity. This is initial now. This is final. So finally it is at rest. v1 square plus g minus and up to what height? h1. So v1 will be what? Under root 2g h1. Okay.
Okay, sir.
But my question is here u1 will be minus. Why? Because it is going down. Okay. Here v1 will be plus because it is going up. Because velocity will tell the direction of motion. The direction of motion is down. It means it will be negative. Net mobile then coming.
Okay, my turn for John.
Calculate u1 is minus because velocity will tell the direction of motion. Initially it is going down. Down means minus. Okay. v1 is up. Clear? Why? It is ball is going up. So v1 is positive. Clear? Now
Okay,
put the value, you will get the answer. u1 is minus. So what is the coefficient of restitution? You will get direct relation. v1 is under root 2g h1 and u1 is minus under root 2g h. Clear?
yes, sir.
Same thing like they solved. Okay. Same thing they got. I also got same.
Okay.
It will be under. This is actually direct question they have asked in NEET or JEE. This same question they have asked. You know what I'm saying? Children are thinking competition is very, very high. Actually, competition is not very high. They didn't learn the things in depth. NCRT only, if you focus on NCRT, many things were there in NCRT. A student is not solving the NCRT properly. Even if I ask physics also, so many good questions were there. Even theory also, they are not learning properly. This question they have asked. That is really drawback.
Okay.
Nowadays, which I am saying now, that is, they should read the books also. Sadly. Okay. So
Okay.
H1 is what? From here you got H1
Okay.
is e to the power square e to the power 2 h. This is after one bounce. Okay. You know,
Okay, sir.
this ball flight first bounce. First bounce. Okay. You know, bouncing. Again it is coming.
Yes.
Again it is going up to this. Again it is coming like this. So it is bounce like this. Bounce like this. Bounce. Again going. Then again coming. Okay. Again bouncing. Again coming. Again bouncing. So you can check H is
Okay.
continuously there. After
Decrease.
nth bounce, it will be direct formula. Hn will be e to the power 2n h. What is h?
Oh,
Initial height from which you have dropped. You can check. Initial height from where we have dropped. Okay.
okay. Okay, sir.
This direct actually many students are asking like this question. Highly very, very important question like what is the height after nth collision? E to the power 2n h. And which case is
Sir,
this?
questions in this lesson are tough on me, sir.
Huh? What
Questions
the?
in this lessons are very tough, sir. Like numericals.
Nothing tough. I'm saying the concept, learn concept. See, things are not tough. We are making the things very tough. If you learn physics, if you feel physics, then nothing is tough. Concept,
Sir.
focus on concept. Did
Okay.
I see the solution? Did I see? I directly apply the concept. Momentum conservation, simply. Conservation of momentum. Direct formula I have applied E will be separation velocity divided by approaching. Did I apply anything? Clear? No need to worry. You can Ask any doubt. You
Okay,
just
sir.
whatever question you are facing doubt now, you just send on group. I will send. I will take care. Okay, no need to worry. Okay.
Okay, sir.
Total
Okay.
distance traveled by the sphere before it stop bouncing. Clear? Distance it is now e to the power.
Yes, sir.
Is my screen visible to you? Hello? Hello?
Yes, sir.
Am I audible?
Yes, sir.
Okay, now see. After nth, what we have learned after nth bounce, height will be e to the power 2n h. First bounce, how much height? H. Second bounce, clear? Total height. Second height,
Okay, sir.
okay? Same thing like, clear? Second bounce, just put n is equal to 2. Like this. I think some network issue is going. I'm telling, okay? See, first bounce. It is coming. Okay.
Okay,
First,
sir.
it strike. After that, it bounce up to this. Okay. First bounce. Let us over it went to H1. Okay. Again, it is coming. See, if it is going like this, H. First bounce, it is going H1. When it is coming down, it will travel H1. Okay. Distance. Second bounce, again H2.
Okay, sir.
H2. Third bounce, H3. H3. Okay. So every time distance, it will travel like this. H plus 2H1. Okay. Then 2H2. Third bounce, 2H3. After infinite. Okay. Is it now H, H1, H1 it go, and then H1, 2H1, then H2, again H2, 2H2. Okay.
Okay, sir.
H1 means after first bounce. Formula will be e to the power 2n. First bounce means n is equal to 1. Okay. H2 means after second bounce. Second means 2, n is equal to now. Third bounce, n is equal to 3. 3 to
Okay,
the
sir.
6. Like this. Once you add, you will get the answer like this. By the way, I will recommend you don't need to learn this also. You should understand the concept. If you wish, you can learn. This distance, total distance, if you want to learn or write the formula, you can write. The total distance traveled after an collision, infinite collision. Not infinite. Once this ball is stop bouncing. Okay.
Okay, sir.
If you want, you can check.
Okay, sir.
What is there? If the ball is dropped from a high touch and the ball keep on bouncing, rising to a height h1, eventually coming to rest. Before coming to rest, how much distance it will travel? This much. You can solve this, okay? Clear?
Okay, sir.
Yeah. Time will be same thing. See, if this ball is going down, it is taking small t time. Bounce, t1 time it is going. If it is going up, for second bounce, before taking second bounce, it is again taking t1, okay? How much time? T, here t1,
Okay, sir.
again t1 because free fall. To T1 up to this. Okay. Again, here it is going second bounce. T2, again T2. Clear? Like this. Is it clear? Nothing to worry.
Okay, sir.
So remember, if you want, you can remember this formulas. Equation of motion they have applied. Average speed total distance by total time. So how much distance it travel?
Sir, can you show the previous slide?
You can write direct formula. How much time? Total time. Under root 2h by g 1 plus e by 1 minus e.
Okay, sir. Yes,
Okay.
completed writing.
Average speed
Okay, sir.
total distance by total time. Total distance we have solved h 1 plus e square by 1 minus e square. Total time. Then finally average speed will be under root gh by 2 1 plus e square by 1 plus e whole to the square. Okay. Okay, Dinesh.
Okay, sir. Okay, sir.
Okay. Average velocity net displacement by total time. Net displacement is h only. Okay. For example, it is
Okay.
on the surface. This is h after infinite collision. Okay. It come back like this. Ball will be here now. Finally. Initially. Okay. Then initial final
Okay, sir.
displacement is how much in y direction? H now. Is the displacement. Okay. Finally, see the
Okay,
final.
sir.
Finally, it is at on the ground. Initially, it is so displacement is initial to final. Finally, it is here only. Initial ball is up to height h. Finally, 0. So displacement is h only. Total time will not time will be same. Okay, previous thing. Okay,
Okay, sir.
tell me the answer.
1 minute, sir. Sir, 1, sir.
Clear.
Sir, option D.
Material, na what I speak. It is independent of the mass. It is independent of the velocity of colliding body. It depends on the nature of collision. For elastic, it is 1. For perfectly inelastic, it is 0. It is ratio. Okay. Tell me. What is the answer? What is the answer? Tell me, Dinesh. Hello.
Sir, option B.
Again, check.
Option B, sir.
Option B. Thank you. So listen, work energy. You just check in your syllabus. Work energy theorem is there or not? Conservation of energy. If it is there, tomorrow I will take your class again. Okay. Today, most of
Okay, sir.
around 60, more than 60%, around 70% complete. Tomorrow I will finish WET, conservation of energy, conservative, non-conservative force, potential energy, little bit, very basic. No need to go in depth. Okay.
Okay, sir. Okay.
Elastic work done by elastic force, these things, basic we will learn. Some numericals also will solve. Okay. So I will stop this lecture now only. If you have any doubt, you can ask anytime. Okay. No need to worry.
Okay.
How is the weather like in Chingalpet?
Sir?
How is the weather in Chennai or Chingalpet?
Sir, very cloudy, sir. Like it's like raining, but not
Oh,
raining. Like
so much
clouds are so
weather.
dark and
Clouds are so
yes,
dark.
sir.
Surprise
Yes, sir.
like weather, like
Wind is blowing.
sudden raining or sudden like weather of south is very surprising, like sudden change, sudden. No need to
Sir,
worry
but
one day.
here it will not be so hot or so cold.
Chennai it is very hot now. Chingalpet I think it's not hot now.
Sir, it will not be that much hot, sir.
Okay, nowadays it is
Like near to my
less.
house, there will be more trees, so it will not be hot.
Okay. Now, nice. Enjoy the weather, learn physics because nature.
But when we go inside that market or bus stand, it will be so hot, sir.
So because place to place weather will vary, na, because of sea. Understand?
Yes, sir. When we go to bus stand or we're near market, it will be so hot, sir.
Yeah. No need to worry, Dinesh. Take care and ask any doubt. After this, we will start new chapter. I
Okay.
will tell. Once this is finished, okay.
Okay. Okay,
If
sir.
you want part two, then I will start part two. If you want part one to be
Sir,
complete first, whatever
Sir,
chapter you
after
want now.
completing this lesson, sir,
Ah.
after completing this lesson, can we again like revision? Like, can we have?
Revision, Dinesh, we need to complete lot of syllabus. I will share with you some document notes.
Sir.
No need to worry for revision.
Okay.
Actually, a lot of things were there, Dinesh.
Okay, sir.
In 11th, already too much syllabus. I want like you to complete entire syllabus. Completion of syllabus is very important. How will you know like these are the chapters in your class
Okay.
11? You are very lucky like you are able to complete this many chapter. Many students are there who don't take 11th as seriously. Really, I'm saying they are taking very light 11th
Yes.
class.
Sir, many people,
So
many students are like that only, sir, in my class
uh,
also.
so you are very fortunate enough like you are studying and you are taking this much content. Okay, clear? So I will
Okay, sir.
start. I will tell which topic I will start. But I will say
Yes,
to
sir.
you, I will suggest you revise. I will share you some notes also. You should revise day to day. You have book on so not numerical. Try to solve
Okay,
numerical
sir.
also. Or I will share. I think did I share a question bank to you? Like okay, I will share. Today only I will share. Okay.
Sir, for lesson 2, lesson 3 also, that, sir.
Okay. I will definitely. I have a list of questions. You just go through.
Okay.
Okay. Definitely I will share. No need to. Okay.
Okay, sir.
Okay. Take care. Bye bye.
Okay, sir.
Good night.
Thank you, sir. Bye, sir.